Our presentation is on a model-based approach to music genre assignment. What is pop music? What is Latin music? What's Bollywood music? The answers to these questions will vary wildly depending on who you ask. Existing music genre assignment is subjective and inconsistent, and there's very little relationship between the technical attributes of music and the genre of songs. A model-based approach of genre assignment will allow record labels and musicians alike to take the guesswork out of their operations by identifying the technical attributes of popular music and adjusting their investments accordingly. We also solve the problem of inconsistent genre. Well, this is the flowchart of our process. Our primary experiment, that's where the value of our study lies, is in finding an unsupervised model that clearly separates music according to the technical attributes into clusters. And a secondary experiment would be to identify a supervised machine learning model that will be a discriminating agent that will make predictions and will classify new and unseen music.
Thanks, John. So as you can see in the previous slide, there was at the beginning, you can see that we obtained the data from the Spotify API. We used a query that of the top 5,000 songs from the most popular genres in 2015. And from Spotify, we also obtained 12 measurements. These are 12 features. Some are confidence scores, some are direct measurements of the actual song characteristics. And in the bottom of this slide, you can see a sample of how these look like. Now, on the next slide, we can see that these 12 features that we obtained from Spotify, they're not very highly correlated to each other, which is good because that means that these features measure different things about songs in different ways. Now, in this next slide, we can see that we used a dimensionality reduction technique called TSNE to represent and plot our data into dimensions, these 12-dimensional data. And we can see also that from this plot that the data, when it's colored by the genres that Spotify assigns, it's not very separable. So that supports John's statement that was said before about how these genres that existed are not the best way to classify songs. Now, Preet's going to tell you more about how we use clustering to classify songs into our new genres.
Right, so moving on to the clustering methods that we use, we started with dbScan, and we did that because dbScan doesn't require you to give it the number of clusters that you want to work with, and we didn't want to make an assumption about the numbers. But the problem with dbScan is that it left a lot of songs unclassified, and it created too many clusters to the point where the clusters didn't mean anything in terms of genres. So we moved on to using k-means and Gaussian mixture models, and both of these models had their trade-offs in terms of the evaluation metrics that we use. We analyzed them using the Davies-Bouldin score and the silhouette score. We wanted clearly defined clusters because these represented genres that had songs that followed the same pattern in terms of like their technical characteristics. So we tried to visualize it, but obviously because the clusters are in a 12-dimensional space, it was hard to do that. We use these radar plots to kind of get a feel of what our clusters look like with the two types of clustering that we did. You can see that some of the clusters are high in terms of loudness and energy. The others are high in terms of maybe acousticness.
For supervised learning, we utilized a logistic regression model, which had the highest performance metrics to predict the labels of our k-means model. This model is utilized to replace humans to help better classify genres of the songs of tomorrow. We do have limitations and future work, but we'll discuss that during questioning. Thank you.